Deep within our bodies, hidden from the naked eye, exists a remarkably complex and efficient defense force, the immune system. This intricate network of cells, tissues, and organs works tirelessly to protect us from harmful invaders. Like vigilant soldiers, these microscopic defenders patrol our being, eliminating threats before they cause harm. From the common cold to life-threatening diseases, our immune system keeps us healthy and thriving. It distinguishes between self and non-self, recognizing our cells and identifying invaders. Once a threat is detected, a coordinated response is triggered involving specialized cells and messengers. This defense system has two branches, innate and adaptive immunity. Innate immunity provides a rapid response, while adaptive immunity is slower and targeted. Together they keep us safe from a world teeming with dangers. Imagine a seemingly harmless incident. You're gardening and accidentally prick your finger with a rusty nail. Though small, this puncture wound provides an entry point for countless bacteria lurking on the nail's surface. These microscopic invaders waste no time in exploiting this breach, entering your bloodstream and multiplying rapidly. This is where your immune system leaps into action, launching a swift and coordinated defense to neutralize the threat. The first sign of trouble is the injury itself. The punctured skin releases chemical signals that act like alarm bells, alerting the immune system to the breach. These signals attract the first responders of the immune system, the innate immune cells. These cells are always on patrol, circulating throughout the body, ready to respond to any sign of danger. The innate immune response is non-specific, meaning it targets any foreign invader regardless of its identity. This rapid response provides a crucial first line of defense, preventing the infection from spreading and buying time for the more specialized adaptive immune response to develop. Among the first responders are macrophages, large amoeba-like cells that act as the body's first line of defense. These cellular scavengers relentlessly patrol our tissues, engulfing and destroying any foreign invaders they encounter. Picture them as the security guards of your body, patrolling the perimeter and apprehending any suspicious characters. Macrophages are equipped with a voracious appetite, capable of swallowing up to 100 bacteria each. Once engulfed, the bacteria are trapped within a membrane-bound compartment called a phagosome. The phagosome then fuses with another compartment called a lysosome, which contains powerful enzymes that break down and destroy the captured bacteria. If the macrophages become overwhelmed, they release chemical signals calling for reinforcements, neutrophils. Neutrophils are the most abundant type of white blood cell and are particularly adept at killing bacteria. These highly mobile cells are drawn to the site of infection by the chemical signals released by macrophages and other damaged cells. Think of neutrophils as the special forces of your immune system, arriving in large numbers to eliminate the threat. Section 4. Calling for reinforcements, the adaptive immune response. While the macrophages and neutrophils are busy holding the front line, another branch of the immune system, the adaptive immune response, is preparing a more targeted attack. This specialized response involves cells called lymphocytes, which are responsible for recognizing and remembering specific pathogens. The key players in the adaptive immune response are dendritic cells, helper T cells, killer T cells, B cells, and antibodies. Dendritic cells act as messengers between the innate and adaptive immune systems. They patrol the tissues, engulfing pathogens and displaying fragments of them on their surface. These fragments, called antigens, act like wanted posters, alerting the adaptive immune system to the specific threat. Dendritic cells then travel to nearby lymph nodes, which are small, bean-shaped organs that house a vast army of lymphocytes. Within the lymph nodes, dendritic cells present the captured antigens to helper T cells, which are crucial for orchestrating the adaptive immune response. Section 5. A coordinated attack T cells and B cells. Helper T cells are the generals of the adaptive immune system. They coordinate the actions of other immune cells. When a helper T cell encounters a matching antigen, it becomes activated. It then multiplies rapidly, creating an army of clones. These cells release signals directing other immune cells. Killer T cells or cytotoxic T cells destroy infected cells. They release toxic molecules to induce cell death. B cells produce antibodies that bind to specific antigens. Antibodies act like guided missiles, neutralizing pathogens. They also coat pathogens for easier destruction by macrophages. Section 6. Lasting protection, memory cells and immunity. After the initial infection is cleared, a small number of activated T and B cells differentiate into memory cells. These memory cells provide long-lasting immunity by remembering the specific pathogen encountered during the initial infection. This immunological memory allows the immune system to mount a faster and more efficient response upon subsequent encounters with the same pathogen. This is the basis of immunity, where our bodies develop resistance to specific diseases. Vaccinations work by exploiting this mechanism, introducing a weakened or inactive form of a pathogen to the immune system, triggering the production of memory cells without causing the actual disease. The immune system is a remarkable testament to the complexity and elegance of the human body. Its intricate network of cells and molecules works tirelessly to protect us from a world teeming with potential threats. By understanding how our immune system functions, we can better appreciate its importance and take steps to support its vital role in keeping us healthy.